So in the previous video, we were looking at an introductory concept to context-free languages, what they are, how they are defined, and what they constitute of. So let's look at some examples with questions from the prescribed textbook. Right. So they say consider the following CFG. What is the language generated by this context-free grammar? Right. So now this is a very a repetitive task that you have to do, and you have to do it a couple of times, not even a couple, but a lot more times for you to get comfortable with this. Right. So what you can see is that all the words is to be generated from the non-terminal S, right? That is a rule. So what does S give you? So S is capable of producing AX, right? So we can generate A, then we go to X. So the first thing that we note is that all words begin with an A. So X, we now investigate what X gives us. So X gives us AX, BX, or now, right? So this is now from before. It gives us AX, BX, or now. So generally, this means you are able to, you can produce, you have got X, you can produce an A, you can over here, you can produce a B, or you can stop at an A, right? A and now, right? Each of these can escalate AA. You can have over here, you can have AX, you can have BX, right? So as you can see that you can generate an A, you can generate a B, you can generate now, you can terminate. But X can generate an A, X can generate a B. So it generates the equivalence of A or B clean star. So this whole thing, it generates the equivalence of A or B clean star. So we are saying if you were to put this in regular expression format, it's going to be A or B clean star. Right. So mind you, not all languages can then come down to a regular expression, right? Because some context-free languages are not regular. So this is just one of the fortunate cases where we can deduce it, or it came down to a regular expression. Right. So looking at this, we can then answer and say, it is indeed a language of all words that begin with an A. Let's look at the next one. Right. Consider the CFG XAXAX. What is the language generated by this CFG? Right. So the restriction is that any word that is going to be in this language is to have these two non-terminals present. Right. So we see that we had this earlier, so this is simply our A plus B clean star, right? So we are saying in between these A's we can have anything really. So we can then come and say this is the language. Right. So that becomes the language generated by this CFG. Right, let's look at another one. Consider the, give a CFG for the following language. All words that do not have a substring AB, right? So this sounds regular as well, but we want to find all words that do not have the substring AB. So we need S to go to, so S can go to A, right? It can go to B, right? What we don't want is for it to go to AB. So if it goes to a B, so this is how we do it. If it goes to an A, we want to make sure that the next letter is not a B. So we take it to an X, right? Then if it is a B, if it starts with a B, we can continue having, we can even say BS, meaning that S can generate a lot of Bs, right? That is accepted. Right? But I would like to put a, let me say, Y, like that. And then also S can go to now, because now does not have an A, B substring, so it is accepted. So from this very statement, now is the only word that is accepted. Now let's define X. So we want X, as long as you have X, right? X cannot be B, right? X cannot be B. X can go to AX, right? X cannot go to anything other than an A. So AX or now, right? So that means you can terminate X as well. Then Y, B's can go to Y, so we've got, when you get to Y, if you encounter a B, you can continue having B's, right? If you encounter an A, you go to X. The moment you encounter an A, you want to go to X, because X prevents you having a B from a Y. And then you also want this to terminate. All right. So this then becomes the CFG of all words that do not have the substring AB. All right. So let's think of a few. Say B, A, right? So what do I have? I have S goes to BY. Y will then go to, I've got BY will go to AX, and then X will go to AX, and then X will go to AX, and then the last X, we have the word that we need now, we terminate it with now, so it's BAA. So you can try, you can pause the video, play around with some of the words that are in the language and try and generate them from the given CFG. Right. Let's look at the next one. Give a CFG for the following language. All words that have got different first and last letters. Different first and last letters. So if it starts with an A, it ends with a B. If it starts with a B, it ends with an A. Right. So I'll say, this is the restriction that I want to enforce. I would say, if you start with a B, you end with an A, right? If you start, I can put this, let me not use S, let me use X. If you start with an A, I want you to go to A. So I can even use X for this, I don't mind. End with a B, right? So, and then X becomes, X can now be anything. We don't care as long as you have different first and last letters. So it will be AX, BX, or now. And then we have our CFG. All right. So feel free to look at more questions, more examples. You definitely need to do more on your own before you get comfortable with this. Otherwise, join me in the next video when we look at more properties of context-free languages.